I am a program manager on the SQL Server engineering team.
I'm Pedro Lopes. I'm a program manager in the SQL engineering team as well.
And we're here to tell you how to modernize your SQL Server environment risk-free, how to take those worries away from you when you're moving to the latest version of SQL. Anything else you wanted to say before we dig in? All right, so welcome. Congratulations for making it to the afternoon of day 4. Thank you for being here. OK, so modernizing SQL Server the right way. How do we do that? So the first question is,
why upgrade?
Yeah, sorry. Is there a way to fix the? I can't see the slide.
Oh, I'll deal with that.
Yeah, if you can fix that for me. Thanks. OK. I really don't want to have to look at the screen. Thank you. A little more.
This is the current slide.
That's the current slide. OK, thank you. OK. All right, so why upgrade? So why do I want to modernize it all? Everything's working great. Like you said, I know something's going to break if I move to the new version. Why should I actually go? And there are a lot of reasons why you might want to go, or you might have to go. The first one would be, do I need to modernize to reduce costs? The newest versions of SQL Server offer you a lot of new features that can do things like automatic plan correction, adaptive query plans, query store that allows you to monitor queries. We make better uses of the resources we have. Things just generally, column store indexes, in-memory OLTP. There's a lot of new features that you could benefit from if you would modernize. And a lot of them will reduce your total cost of ownership. So that's one reason. Maybe industry certification. Either you need some of the new security features to remain industry certified, or you just need to be on modern hardware, modern operating systems. Vendor support is another one. Either vendor support from Microsoft, we may not support your version anymore, or if you have applications that need to maybe remain on an older version or they need to be on a newer version, that might tie you to a version of SQL. ISVs, so maybe you're writing your own software for your own customers and they want to modernize and your app isn't certified. So there are all these reasons why, and so what we want to tell you is how. So that's really what this session is about, is how do I get there? So one last thing for the why, and that is, clicky, there we go. Winter is coming. I saw a lot of you that were still on 2008. Why am I saying that winter is coming? Right? July 9th, 2019, end of support for SQL 2008. So I hope, how many of you that are still on 2008 are already planning your modernization strategy? Good, okay, so we've got a lot of hands here. So if you're not, hopefully this will help you. So I'm going to hand over to Pedro for a little while, and he's going to talk to you about dbcompat, which is one of our methodologies.
It's actually one of the reasons that those that know what will break and those who don't know what will break often fear. It is the pivotal, let's say, concept that can make or break a post-upgrade status, meaning after you successfully attach your database to the newer SQL Server system or Azure SQL DB or Azure SQL Maintenance Instance, will my workload run the same, at least, if not better? That's the fear of the unknown there. So, and that's all tied to the concept of database compatibility level, in this case, base certification. Why? So the first thing I would like to call out is everyone that's in an ISV specifically, and if you're certifying your applications based on a given platform, oh, I'm certified for cloud, I'm certified for SQL Server on-prem, but not cloud. Stop thinking about that. We have exactly the same SQL Server engine, the same code base running on all these platforms. SQL Server on box, SQL Server managed instance, Azure SQL DB managed instance, and Azure SQL DB, the normal single database PaaS service. And also stop certifying for a SQL Server named version. Now, I know this is a mindset change, and it might not be easy to get there, but think about it for a moment. If you are an ISV or any developer that has certified their application for SQL Server 2008, for example, intrinsically, you have probably chosen the highest dbcompat level in that version, which is 100, which means that you've done all your tests, everything around dbcompat 100. That actually means you didn't certify for 2008, you certified for dbcompat 100. Fast forward a number of years, every new version introduces another dbcompat level, which means that each dbcompat level introduces new changes, new optimizations to the engine, namely to the query optimizer. Well, what does the query optimizer do? It's responsible for taking our T-SQL queries, parsing them, running through a series of optimizations, and on the other side comes the execution plan that's driven to execution. And it's throughout versions that these optimizations may change the shape of the plan and therefore influence performance, hopefully for the best. That's our expectation. But the unknown is sometimes it can actually go south, which is why it's so important to keep in mind the concept of dbcompat level. So I need to start thinking about what target dbcompat level am I certifying to, and then wherever that dbcompat level is present, in whatever version, then as long as my customer or myself keep my database in that compat level, I am certain that I will get the same outcome in terms of optimizations and therefore plan shapes and query plans, and therefore I have the same, all else being the same, I have the same expectations in terms of performance. There's a question there. Yes?
What success have you had in getting Microsoft apps to follow this?
So the question is, what success have I had with Microsoft applications following this? We have started this very, very recently, and we have had some success. For example, SharePoint is planning to do this for a future version. They will certify on dbcompat level. We're working with other divisions inside Microsoft to move to that mindset. As you put it very, 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 very well, it is a mindset for developers inside or outside Microsoft. And it's not an easy concept to shift from. So we have, by the way, we have updated all the public documentation around what I just said with a lot of content. Now, what I mean to say with all this is that we stand by dbcompat-based certification, meaning that we use purposely the term protection, meaning that if you stay within a certain dbcompat level to where you certified originally from, we will protect you against changes to the query plans that usually are the ones that introduce risk and may affect your workload. So there's a few details to this protection that we provide, which is, first of all, we have assessment tools that can run through your code and through your workload to provide you insight on whether you have deprecated code or discontinued code. That's one. Obviously, discontinued code, code that was removed from the platform, doesn't run even on older compat levels, even though you're running newer bits of the engine, but older compat levels, if we remove something from the T-SQL notation, it's still not there. So the first thing you need to do once you plan an upgrade is to point our tools, and I'm going to show them which tools these are, to your databases, to your workload, to make sure you don't have the risk of unexpectedly hitting discontinued code that obviously will not work in a higher version. The second one is, like I said, we provide query plan shape protection. This is a mouthful. What is this? So like I said, the query optimizer creates query plans. Those drive the execution of our queries. Now, if a newer version with the changes that we introduce in every newer version change the shape of the plan, that may actually introduce a negative effect in parts of your workload. So we protect you against that, which means that if you keep your database in the same source compat level for whatever time it needs for you to move onwards, then you are protected against that, meaning you can modernize your SQL Server platform either to a newer version of SQL Server or Azure SQL DBMI, for example, and still keep the source compat level, which means that you are protected against the risk of regression from that. And that is because the unspoken feature of SQL Server, and for the SQL Server team, that we strive to upkeep the most is backwards compat. So that is the unsung feature of SQL Server. Now, the key benefits of certifying on a dbcompat rather than a named SQL Server version start to unravel. For example, if I have a single certification process for my app on dbcompat whatever, then that means that if I choose to migrate my app to Azure DBMI or to a newer version of SQL Server on-premise, as long as I keep that fundamental assumption that I have the same dbcompat, then I'm free to choose my platform, because the engine is the same, like I said. The other one is, if you're an ISV, for example, the ability of your customer to choose wherever they want to go. It's up to them. You provide freedom of choice to your customer, to your own platform. Again, you keep the asset of, I've only certified on that DB compat level. And then, even for you as production DBAs and folks that are in boots on the ground, tackling these upgrades and these modernization cycles, and for ISVs, you are able to decouple the modernization cycles for the database layer and the application layer on top. You are reducing risk. It's common enough for example, large ERP software upgrades to tackle the database layer and the application layer on top at the same time. So this introduces risk. If you are able, for example, to migrate and modernize your database layer, keeping DB compat, whatever issues may or may not arise from there, you tackle them with, in this case, the software vendor for the database service being Microsoft. And then once you've stabilized, if needed, the database service, then you tackle application upgrade. And when that time comes, you flip the switch for DB compat if needed. That reduces risk considerably. And reducing risk means less nights awake trying to solve problems because something went south when you're tackling the upgrade. Now, it's not a universal panacea, if you will. You don't want to stay necessarily on the source compat level for the lifetime of the product. We have stopped, as you've probably seen in the last couple of versions of SQL Server, we've stopped removing the older compat levels. So right now, for example, in SQL Server 2019, we support all the way from DB compat 100, which is 2008, to 19, which is DB compat 150. Which means that if you need to leverage newer features, if the application that you are supporting in your database will leverage these newer features that Pam mentioned in order to unleash the power of data there, then obviously you will need to eventually certify and move to a higher compat level. But you can choose for the interim, whatever time it takes, 1 year, whatever, to stay in the previous compat level just by upgrading the bits of the engine while your application goes through its certification cycle for the next DB compat. And to know more about the roadmap for SQL Server, we do, or there was a session that you can attend online now on the roadmap for SQL Server. Most features that have to do with query optimization and therefore may affect negatively the shape of your plans and therefore the performance of the workload are protected under compat levels. So again, when you stay in a specific compat level, you are optimizing and running the queries like that previous version. However, we have added a number of scalability enhancements to the engine over versions, auto-soft NUMA, a number of memory grant corrections, and a number of other issues that, or features that we've introduced that are at the engine level. Those will provide you scalability and added performance, but not at the expense of query optimization. So you may leverage newer bits by still keeping a foot in the stabilized workload you had before. So I hand it over to Pam now.
Okay.
We'll go in to look at the upgrade process itself. What do we recommend in terms of the upgrade process?
Great. So what we want to talk about now is how are you going to get this upgrade done? What's your process? And one of the methodologies Pedro was just talking about is let's separate the application from the platform and let's get that database up there, and then you can bring your application along later. So in the planning, in order to be able to do something like that, you need to have an idea. The first step of DB compat is have an assessment that runs clean, a functional assessment that runs clean. So that's kind of the key to this process, is most of the work that you do for a migration should happen before you even start upgrading bits and building new servers. The work that needs to be done is on the, do I have a pointer here? It's on the left part of this cycle here. All of this happens before the cutover. The cutover, when I get to the new server, that's the very last thing. You can see there's a lot of work here. So this is our migration process, and this is something that's illustrated in the database migration guide, which is something that's available online. I have links to this in the slide deck in the notes. But you can also just do a search for Microsoft Database Migration Guide. And this is a way that you can get through this modernization process, minimizing risk. so that you can do the discovery beforehand, do the testing beforehand, figure out all the things that could potentially go wrong, and try to correct those issues before you get into the new platform. Because the last thing we want to do is be troubleshooting this stuff in production when you've already migrated all the data and you've already done all this work. It's a lot easier to go up than it is to come back, right? So we want to get this done ahead of time. We want to do all this before we do that cutover. So that's what this process is all about, the database migration guide. So in the first section here, sorry, I want to make sure that my animation, looks like my animation went away. So the first thing we want to talk about is, sorry, my bad. The overall process. So fully automated using free tools from Microsoft. So every step of this process, we provide you with tools that will allow you to do this, and these tools are free and available to download from Microsoft, and you can use these tools to do all of this testing and assessment that we're talking about. So the first one we're going to talk about is for the Discover phase, which is called the Microsoft Assessment and Planning Toolkit. This thing's been around for a long time. You may have used this before, and if you already know your environment very well, you might not need this particular tool, but this is good for people who have very large enterprise environments with many, many instances of SQL Server, and you may not know what you have out there. You may not even know how many SQL servers you have. So this is a tool that helps you discover your environment and figure out what you have out there. How many databases do you have? What versions are they running? What does the hardware look like? How many cores? What's the size of all my databases? And that can help with that. I think I see a question in the back.
I was told recently that this is no longer being developed at Microsoft. You know who owns it now?
It's no longer being developed by Microsoft?
The map toolkit is no longer being developed by Microsoft?
It was updated recently, so I don't know where you got that information from, but let's take that offline.
We can follow up with you offline, because I'm not sure where that came from. Okay. So the next part is the assess phase. So the tool we're going to talk to you about today is called the Database Migration Assistant, or the DMA. And this is used to do that initial assessment that Pedro was talking about, where we look through the database and we look through your code to see if there is anything that might potentially be a deprecated feature or a migration blocker. And then the last one is the test phase, for which we will recommend the Database Experimentation Assistant, or the DEA. And all of these are covered in this database migration guide. So if you want more details, and this is what we're going to talk about, we have some demos as well. So I have some quotes that are going to pop up here. We did a session in past last year where we talked about this process. And so we have a customer that's gone through this and has done this. And it's just kind of, I won't spend too much time on these, but you'll see them pop up throughout the deck that talk about reducing the time and effort, minimizing risk, and upgrading with high confidence using this process. So this is a tried and true methodology. Okay, so the first one is the Discover phase. So for the Discover phase, we've got the map toolkit. So again, which versions do I have? Which editions? Which components? How many cores? How many databases? What is the sizes? And what are all the settings? So that will help you kind of have an idea of what you have that needs to be migrated. If you're doing any kind of a consolidation effort and you're trying to move databases together into the same instance, this can help you with that. If you're just trying to get a sense of how complicated your migration is going to be and what you need to get to your new environment, the map toolkit is a place to start. If you've only got 1 or 2 servers to do, you probably don't need to do this. You can just eyeball this kind of information. Yes? Okay, so the question is, when are they going to give us the ability to schedule the map toolkit runs and pull the data out and put it somewhere else?
We don't have insight into that.
Yeah.
At this point, we're users of this, but we'll gladly take the feedback back to that team. It does export to Excel, which then you can... Excel is a very common tool to make these plans. Mm-hmm.
Uh-huh. I see what you're saying. Yeah, just to be clear, this isn't a database-specific tool. This is an overall Windows assessment tool, so we don't actually own it. But yeah, we can take that feedback of needing an automation and a way to collect that data. Yeah, that definitely makes sense. Thank you. All right, so the next step would be assess and convert. So for the assess and convert phase, you would leverage the data migration assistant. So what the data migration assistant does is look for compatibility issues. Do I have any breaking changes? Do I have any behavior changes that could influence how my code behaves, how it's interpreted, things like that? And are there any deprecated features? Now, moving forward, like Pedro said, we know that one of the biggest issues with the migration is the fear that something's not going to work anymore, that something's going to break, that we're going to take something out of the product that your application relies on. So what we want is for you to feel confident that you can do this modernization without breaking anything. So this will help you discover that, but also we're trying not to take any deprecated features out of the product. We might say, this is deprecated, we're not going to put any new development into it, but we're not going to like pull the rug out from under you. We're going to try really hard to make sure that this
Let me make
works.
a statement there.
Yeah, sure, go ahead.
And so about deprecated features, for all intents and purposes, we have effectively stopped deprecating features. We reserve ourselves the right to discontinue some feature in the future, only in the case that it may limit the development of just the progress of SQL Server itself. So the previous, let's say, policy from years ago that we support every feature until n-2, and then we may deprecate, and some features when you get a new one, the old one deprecates. We have stopped doing that. What's deprecated right now in the deprecated state, it is deprecated, but we're not doing that actively anymore.
Right.
Just a couple of quick examples, because I've gotten questions before about what's a breaking change and what's a behavior change, and what's deprecated and what's discontinued. We have a link in this slide, or if it's not there, we need to put it, that explains exactly what each of these nuances are. For example, a breaking change is something that it's what, let's say you call a DMV, and the DMV, for example, the CMDB OS memory, if I'm not mistaken, up until 2012, it showed multi-pages and single pages. And because we changed the memory model in 2012 and above, it shows pages KB. The DMV is still the same if you call that object, but we have changed some of the columns there, so that may break some of your code. That's a breaking change. So it's not something that's gone away. It's something that you need to pay attention to that and make the necessary changes in order for your code to work. A quick example on behavior changes are, for example, starting with SQL Server 2016, we have increased the accuracy of numeric and decimal data types, and even date data types, date time. And for example, if you have an application that's working in SQL 2008 or 2012, and you're using date time, for example, once you and you have some query that makes that has a where clause that compares column X, which has date time, with a conversion to date time from somewhere else. Well, when you move to 2016, that conversion that you're doing actively in your code will benefit from this added precision, but then it may not match the quality of the clause that you were trying to issue. So it's a behavior change. So it doesn't change your code still works, but the outcome may be slightly different, and you need to account for that. That's what these tools do.
Yeah.
They will let you know what changes there are that may affect and may add risk to your upgrades.
Yep.
Sorry about this.
Yeah, no, that was great. Good information. Thank you. And so that's going to help you zero in on anything that could be a potential issue. And then you can work that out in the testing phase. So you can make whatever changes you need to make. You can specifically look for those behavior changes and make sure that they're not causing you any actual issues in your application. So this is why this is the discovery phase. We're basically looking for anything that could trip us up at the actual migration point. So the other thing this will help you do is also discover new features. So are there new things in the product that may help improve your workload? Can you leverage any of these new features? Is there anything that we can recommend for you to do after you implement this upgrade? Should you maybe change some of the data types that you're using? Should you maybe change some parts of your application to take advantage of these new features? So that's another new set of things that you can get recommendations from the DMA tool. And the last one is this can actually perform your migration for you. So this can then generate scripts that you can use to migrate your data. And generally what I recommend is you take the DMA, you can generate the scripts to do the migration, do that into a test system so that you can then go to the next phase and actually test out your code at the new version before you do the cutover. So when you do the actual cutover, you may be doing things slightly differently. If you want minimal downtime, maybe you're actually leveraging replication or availability groups or log shipping or something like that, where you're actually moving things over to the new server while your old server is still live so that you can minimize your downtime for the actual cutover. So even if you don't use this to script the actual migration, you can leverage this to get yourself into a test environment and start doing all of your experimentation. And then I just have one more call out here. Again, Database Migration Assistant allowed us to identify potential pitfalls and to automate remediation. It can generate the scripts for you to do what the recommendations are. So any questions on the DMA before we move on? Yes?
Question. Oh, that's okay.
Does it recommend like indexes? Is that what you're saying?
So the question is, does it scan the environment and then allow it to, does it recommend changes like new indexes and whatnot to make sure that?
New features, so it may suggest new features, but not things like new indexes. So it's not going to do like performance tuning recommendations, but it might suggest like, I don't know.
One clear example would be, by the way, so the DMA tool, what it assesses is the static schema in your database. So we're not at the part where we're scanning workload yet. That's a different thing that Pam is going to talk about. So you point to a database, or a number of databases. It scans through your schema. So if your application leverages mostly functions, stored procedures, and whatnot, it will be able to scan those. And it will be able to identify these pitfalls in those objects. And it will be able to, if you're using any discontinued or any change that would break the upgrade, it will provide a recommendation on how to circumvent that. It will also, at a later stage of DMA, allow you to run a number of wizards, for example, to see if that database is eligible to take advantage of in-memory OLTP or column store, for example. Those are available as separate wizards, but you are able to run them in the context of this process in order to see that, oh, okay, now that I have my database there, is there something that I can do to improve it without actually changing my application on top of the database, for example, leveraging column store? And those wizards they're also available in SSMS, but we are leveraging them in DMA tool as well. Does that answer your question?
Yeah.
Okay.
Okay.
There was another question there, and then we need to move on.
Yes.
Yes.
This will look at your stored procedures. The only thing it cannot look at is if you have any ad hoc queries. There's no trace analysis functionality. So it will look at stored procedures, functions, anything that's static in the database. But it can't look at, it doesn't have a tracing functionality, so nothing ad hoc.
So for the question is, yes, it looks at any static object inside the database. Yes. We'll get to that. We'll get to that.
Right, this tool won't do that.
It's not this tool.
The next one will. Yeah, this tool won't. Okay. Other questions?
I think we can move.
Okay, great. Okay, so the next phase would be the test and optimize, and this would be a cyclical phase. So you would probably test, make changes, test again, make more changes, look at the query plans, all those kinds of things. Maybe test the new compat level, go back to the old compat level, and do some experimentation here. So for this, we recommend using the Database Experimentation Assistant. So this is a tool that is an A/B testing tool. This allows you to run tests against old version, run tests against new version, run tests against old DB compat, run tests against new DB compat, and compare the results. So this will give you the ability to also look for execution errors. So what this tool will allow you to do is assess your workload. So if you do have ad hoc queries, this does trace or extended events analysis. So it will take that information in. It uses the distributed replay utility to do this. Is the OSTRESS stuff live yet? Or?
It is live in the
Okay.
latest version. Yes.
So there's another option to use OSTRESS as well to do this kind of analysis if you don't want to use distributed replay. And so what this can do is fire similar analysis as the DMA, but for your ad hoc workloads by capturing a trace.
And I have a couple of screenshots coming up. You'll see exactly what we're talking about.
Yeah.
So in essence, you have two, for you to be able to assess the readiness of your T-SQL, you have two tools. You have the DMA to look at static code inside a schema. You have DEA, which amongst other things that Pam is talking about, can look at your ad hoc queries and have the same kind of insights into breaking T-SQL that won't work in the newer version. Some test server.
Yes, you would replay it against your test server. So what you would do is you'd capture the work, like you said, capture the workload in production. You would maybe use the DMA to generate the scripts to do the migration and pre-identify any issues, get those fixed up, and then when you're in your test server, run that workload through the DEA against the system. And you can do it. You can run it against the old version and the new version. And again, you can run against old dbcompat and new dbcompat. And what the DEA will do is do some comparison analysis and try to identify any issues that are coming just from the changes in the engine or the changes in the dbcompat. And so what this will do is it can look at things like configuration settings, it can look at hardware comparison, and it can compare the workloads against the different environments, and then this will flag issues saying, hey, we saw that you had this type of a regression when you move to the new version, and it can give you some suggestions on how to remediate those.
In essence, the question that everyone always has, which is, will I be better off after I migrate? You can answer with this, because it will literally give you, and we'll see visually, a ton of comparison information that will literally tell you in what state you would be in related to your workload execution in the source system and in the destination system. And that will allow you to answer that question before you move there.
Okay. Yeah. Will it tell you if your query plan has changed in different environments? Yes, it will highlight any queries like that. Yep. Any other questions?
Let's move.
Okay, so now this one is also, you can use this with automation. So you can create scripts that run this tool, get the analysis, and extract it for you. So this is something that you can automate if you've got large number of databases and you have a lot to get through. You can automate that. Actually, the DMA is, you can automate the DMA as well.
Yes, you can.
Yes, DMA you can automate as well. Okay,
So
I'll kick it over to Pedro for a demo.
So this will be like a static demo in the sense that setting up DMA, setting up DEA takes a few minutes. It's not something that you want to demo necessarily. So I'm going to run you through some screenshots that show you what relevant information you can get out of these tools. So I can try to zoom into this. Do we have zoom it?
On that? Yep.
We can do this.
Okay, perfect.
At least that's the beauty of. So this is the initial screen of DMA. You connect to a server, and then it will show you this. And the first thing it will ask you is, after you point to a specific database or set of databases you want to upgrade just by clicking, what do you want to do in this assessment? So in this case, as you can see there, we've selected look for compatibility issues, meaning something that may prove to be an upgrade blocker between my source system and destination. But by the way, I want to leverage new features. Do I have anything that's eligible to use in memory LTP or a newer feature of SQL Server? So I want to do that complete assessment. So that's what I choose here. And then I would click Next to move to my next screen. And once I do that, I have a pre-assessment. So the pre-assessment is, we point to the source system now. So remember that I want to be able to know what and how I can upgrade the source system to my destination. So the first point is connect to a source system, in this case 2008 R2. And I'm using Windows Authentication and all the bells and whistles here. There are some notes there regarding the user that runs DMA needs to have those permissions on the target system that you are looking at. Okay, so that's important to keep notice. Then once you move to the next screen, it will take its time because it will scan through the schema. It will run the entire recommendation process. And then you are left with this type of output. So in here, we have an inventory. We just pointed to one single database. That's what we had. And notice that in this inventory phase, we have the source database was in 80 compat mode. There was someone running Windows or SQL 2000 here. This database was initially with 80 compat level. And it was attached to a Windows 2008 R2. Now, because we were targeting, in this case, I want to target DB compat 140, because if I'm going to Windows Server 27, SQL Server 2017, if I can, I would like to go to the latest compat level. Then this gives me a list of breaking changes and behavior changes that are found in my database. Now, if I would choose, for example, oh no, I'm actually moving to SQL Server 2014, which is 120 compat level. I would change to that tab, and I would see only the issues that would affect my upgrade from the source, which is 2008 R2 in this case, to that destination, which would be 2014. I actually just contradicted myself, because I've been referring to versions, haven't I? But I should be referring to the
compatibility,
DB compats,
yeah.
which is what we have here.
DB compat, not version.
So let's talk about DB compat targets, not named versions. And therefore, I can see, for example, that I have code there in my database that's running discontinued DBCC commands. Or I have, SQL Mail is configured in that server, and I don't use SQL Mail anymore. The T-SQL notation for browse is not allowed anymore. And you see then in the same screen, as you click through any of these categories, you'll see details of that issue. You'll see the recommendation to overcome that issue, and it will be scripted out, by the way, if you choose to. And it even tells you which objects in your database are affected by that specific category of issues that you just clicked on. So you're able, from one single spot, to be able to, targeting your fixed schema in the database, you're able to uncover all these potential risks. And then this gives you the ability to export a report to Excel, for example, and you can use this at scale. And run this and send to someone else, and you have the ability to send to your devs, and here's the things you need to be attentive to before we even tackle the migration. These need to be solved. These are breaking changes that will not allow this code to run in a newer version of SQL, maybe irrespective of the DB compat remaining the same or not, because these are discontinued, removed features from SQL Server, and therefore you need to account for those. So this would allow you to look at the schema, the static schema. Then you have the DEA tool. The DEA tool has a similar two-stage approach to it. The basic workflow is this: you capture a workload in the source server, maybe your production server. In the latest version that's available of DEA tool, which you can download at Microsoft Downloads website, it's actually using extended events rather than tracing. And then the second action there is to replay the capture workload against target one. Target one would be whatever mimics your source system. Hopefully you won't run it against the production system itself, but something that mimics that production system, because we want to get execution metrics out of that source system. Remember that we're doing A-B comparison. And then we need to run the same workload, so it is the same captured workload, against my destination system, the one that has the newer version of SQL Server, the one that has my better hardware, for example. And I run exactly the same workload there, because remember, this was captured from my production server. And then it will analyze these traces and give me a number of outputs. Now let's look at a couple of examples. So I would click here, and that would connect me to, I would go and connect to a server, much as I did with the DMA tool. And then the output, after its analysis, will be something like this. So, for example, for the project, this is project-based, by the way, the tool. So I created a project called 2016 Migration, and I pointed to that 2008 R2. So for the project 2016 Migration, I have two targets. I have 2008 source, that was my source system. And I have 2016 destination. This was an upgrade to SQL Server 2016. And what kind of information do I have? I can see, for example, the query distribution By execution count, I see that 27.9% of the workload I captured actually degraded in the destination system as it relates to the source system. I can see that 70% of it actually improved. And these are links, by the way, so if you click on them, you'll get further detail exactly to which objects are affected. You can actually see here that you have a number of queries that are upgrade blockers, some that are new errors that exist in the target or the destination system that did not exist in the source system. So these are, for the most part, these are pieces of code that did not execute or executed with error in the source system. You would look at those. That probably means discontinued transact SQL. And because the workloads have errors, it will show you also what statements add errors in the source, and they keep the same errors in the destination. So that's probably a different category that you don't need to necessarily account for as upgrade blockers. So I can see a number of the errors IDs here that were found in both destination and source. So those are all documented. I can easily click on those and get immediately context of what I'm seeing. But what I want, and here at the end, you see the improved queries and the degraded queries. So you can actually see the query text of, in this case, what improved. And you can see, for example, because I've chosen the metric of duration, I could choose a different one. I see the mean duration in microseconds on both the source and the target, and therefore the difference. So I can see the query number 1 actually runs 90 seconds faster than in the source system. Another type of output I have, yes, there was a question there. You need the same database running there. So whatever a workload needs to run, if this actually replaces the workload. If there's a hollow schema there, if there's something empty, then you don't really get the sense of the queries executing and taking whatever time it takes. So you need to have the same database, or if it is a VLDB, then at least a sizable amount that will allow you to then extrapolate towards the actual production system. And then, the next thing you can see with the EA, which is relevant for what we're seeing here, are the upgrade blockers. So it can actually tell you which ad hoc executions had errors that map to upgrade blockers, meaning T-SQL that does not exist on the target version. So therefore, whatever uses these statements cannot move to the new system. You need to account for those still in dev time. So with this, you have the ability of checking out your ad hoc code. With DMA, you have the ability to check out your static code, and that gives you a full sense of whatever work you need to have ahead of you to tackle your upcoming migration. You can see, so the error ID, you can see the amount of times it happened, and you can see the error text. In this case, because we were kind of faking a botch migration here, we have a few queries using the compute keyword. The compute keyword is no longer supported in T-SQL notation. So therefore, you need to check. There are workarounds, and in the documentation, we show you what you need to change in your queries that are using compute. But then you need to actually enact those changes before you change your code over. Any questions here?
One over there.
Okay, one question there.
Just curious, when you run this against your, say, your production environment after that, is there a resource hit during that process time?
So the question is there a resource hit once you start collecting your baseline, if you will, from my production system? Well, we do need to capture, we use X events instead of tracing, so be sure to go to a DMA version that supports X events. That would be the latest one. Previously, we were supporting SQL tracing, which does have its overhead. We have made it as much lightweight as we can, but be sure that doing a trace like this, even using X events, has some overhead. It may be negligible for your system. It may be higher. So if you're running your system at 90% CPU, botching on I/O, you probably want to get to a better state before even you attempt to add more to it, right? So my final answer would be it's a reasonable overhead, but your mileage may vary there. Okay. So then if you're ready to do the cutover, then you've run through all this process, you've resolved all the errors, you were able to successfully attach your database to whatever destination server you have in mind. And are you done? Well, I would argue you're not done. Because after you move the data, after you are able to successfully run the database service on its destination, that doesn't mean that you're out of the woods. Because even though functionally your Transact SQL now runs on the target system, you may have issues with how it runs in that target system. So the post-migration step is very crucial here to uncover any potential changes in your performance, especially if you have not run the DEA tool, the experimentation assistant that would allow you to do the A-B comparison. If you have skipped that stage because you don't have the time or the resources to do it, then it becomes a greater unknown when you move to the new system whether it will yield the same performance or not. So we do have a recommended upgrade procedure I can't stress enough, you need to go through it before you bump up DB compat. So once you move your databases to the new bits, the new version of SQL Server or Azure SQL DB MI, you should keep the databases in the source database compatibility level. So if you're coming from 2008 or 2008 R2, keep the databases at 100 compat level. Keep it there for as long time as you need to accrue insights into your workload. Now, that would mean that at that point in time, after I have my databases there, I need to leverage one of our newer flagship features, the Query Store. I'm going to talk a little bit about Query Store in a few minutes. Just at this point of this process, you need to know that you need to enable Query Store. And then, because you are now running that in a production system, your databases are already there. You've done the cutover. Your users are using the application and therefore the database as they need to. And Query Store, being a flight recorder, is recording performance data over all your queries that are running. Once you're satisfied that you have run through your business cycle, if that's 1 week, 1 month, it's really up to you, then it may be the time to evaluate flipping the switch to move to a newer compat level, the latest probably, because you'll need to leverage newer features and specific enhancements that are tied to the DB compat level, like I mentioned in the beginning of our session. So at that point, because you've already created a baseline, you will bump up the DB compat level, and then there may be regressions in some parts of your code. And that's when we have a number of tools that can help you. Now, at its most baseline, if my target is 2016, SQL Server 2016, Query Store itself has a report dedicated to showing you which queries have regressed. Regressed from where? Well, if I had a baseline, I bumped DB compat and I'm running in a newer version of the system, if you will, it can tell me what regressed from that previous baseline status to the current status. If we're on SQL Server 2017, however, we have a feature there that will actually recognize this difference, this degradation automatically, and automatically make sure that that plan, that query execution goes back to the previously known good plan. Without even you doing anything, it will do that. Which means that you're a DBA, you come in the morning, you can actually see a glitch occurred somewhere in the evening, but because you ran through this process and you had a good baseline of how the system should behave, like in the source system, it was corrected automatically, and therefore, you are able to reactively go in and see what happened during the evening, for example, while you were off. You just saved yourself a call saying, my system just went out. So in case you missed my session in the theater today, we have added another tool to this, to our tool belt that aids, that assists you in this upgrade process. And I'm going to talk about it in a few minutes. So this is really the process you need to keep in mind. Just because you attach a database, it's still not over. So let's talk about Query Store. Query Store is the flight recorder for all your workload. It's enabled by per database, but then per database it allows you to have, this is using SSMS in this case, allows you to have a number of insights into the current, the state and the past state of all your workload that ran through that database. In this case, I can see there the top resource consuming queries. Or I have another one that allows me to see the regressed queries. So queries that are now behaving worse than they were at a specific point in time. So if I click, for example, on the top resource consuming queries, I have this kind of visualization here. I can see that, for example, this query right here, I can see the query plan. So if you're interested in analyzing the query plan, you have it right here. But I can also see that this query, this execution, has 2 plans in the cache. So I'm able to see that one plan, plan number 1, consistently behaves better, because I can see in that chart over there, consistently behaves better because it has lower execution times than plan number 2. And if this is moving constantly, what I may want to do here is to select my, by the way, I can change the metrics there, but I could select plan number 1 as I see it there, and then I have a, does this have a, yeah, I can click on the button Force Plan, and what I'm doing in one click is fixing my regression manually. So I can go to my regress queries report. It will look something similar like this. I can identify queries that have more than one plan. If I see that one plan consistently behaves better than any other, and I want to force that one to behave always the best it should, then I can, with one click, make sure that it does that going forward. Or, using the SQL Server 2017 auto-tuning feature, it will recognize this, and it will enact that click on your behalf, and it will force the plan on your behalf. Now, I can change the metrics and analyze my workload in any number of ways. So this is not only a reactive feature for you to go in and react to some issue that's happening right now. You can get insights into your workload. So I can drop down there and look at any other metric you see on the screen here. So if I'm interested in looking at my workload, not from a CPU consumption perspective, but rather from a memory usage perspective, or how much I/O have I done, you can do that. You select the metric here. And what is the time interval? Do I look at the last 5 minutes, which is the default, or the last hour, or the last day, or whatever I want to look at? And in SQL Server 2017, we have now also included the wait types, the wait times. So we can actually analyze from the scope of where is my workload waiting on. Is it waiting on memory? Is it waiting on I/O? Is it waiting on some internal structure? So it will give you that information here. And you can really get insights proactively into your workload. If you're able to analyze your workload that happened in the past, you may be able to uncover some trend that may be up and coming and enact some change before it becomes a problem. So, like I said, in SQL Server 2017, on top of Query Store, we have added a new feature called auto-tuning. It's actually a family of features, one of which is the automatic plan regression correction, sorry. So what that does is, because you've run through that baseline, it can identify a regression in your queries in terms of resource usage, and then automatically fix itself. So you can see here, this is the scope of that process of database compatibility upgrade. For a certain point in time, I kept this query running in the old compat level, in the source system compat level, so it was running as expected. A certain point in time, I bumped DB compat level, and this query specifically regressed because I can see here that the query times go through the roof. Now, because I have auto-tuning turned on in this database, it will recognize that pattern has changed, and because I have a previously known good state, it will force me back to that previously known good state, and that will be locked going forward. And it will do this for you. So this severely decreases or eliminates the risk of a database upgrade. Because when you bump up DB compat, after you sorted all the stuff with your code that we've mentioned in the session, you're still left with the unknown of going to a newer compat level, and what if my queries get executed differently? Well, now you have a way out. But this is only possible if you have gone through that stage of creating your baseline. If you go in straight to the new system, bump up DB compat, you're working, and you haven't done any tests before, there's no baseline to go back to. So this specifically wouldn't work. For that, you might want to use the tool I mentioned. I did a session previously today. So let's do a very quick demo on automatic tuning here. Let me change to my...
Any questions while Pedro's changing
Yes.
over? Yeah.
Once you force the plan, does it get any over time if you start to perform poorly? Does it show up in the other reports?
So the question is, if you force a plan and over time the query performance degrades again by some other reason, does it show up in that other report? It will show up because if you have, well, let me put it this way. if you haven't cleansed whatever is in the query store, you still have access to the other plans. So you can unfreeze that and go back. However, you have another report there, which is the top resource consuming queries. That plan that you previously froze, is that the word? You frozen?
You froze the plan,
yeah. It will show up in the top resource consuming queries because it's now become a top resource consuming query. So first thing I could do there, unfreeze the plan. Maybe it will recompile, and now I have something better because updated statistics, created indexes, whatever. Right? So
Yeah, it won't be excluded. It may show up. It just might not show up on the regressed queries. Rather than being a regressed query, it'll just be an expensive query.
It will not become an expensive query, and the first thing you should do is unfreeze it. Let's see what the system does on its own.
Right.
Maybe you have something new there.
Right.
So let me start running here some workload. And let's run. OK. So this is my laptop, so bear with me. The numbers of this is the performance counter for batch requests per second. Because this is my laptop, the number is very small. It's not in the thousands. It's in the mere dozens. So my workload is running. It has the throughput that I would expect. But then I introduce some performance regression. And when I introduce a performance regression, I can see that my performance tanks. Because now the number of batch requests per second is lower, and it is consistently, it will show that's consistently lower than it was a minute ago. Now, at this point in time, I don't have auto-tuning turned on. So what do I do? Well, if I'm in SQL Server 2016, auto-tuning is not there, but query store is. I can go to query store, and this would show up in the regressed queries report. And therefore, I could enact some change immediately from there. However, if I actually have auto-tuning turned on, then let me reset all this. No. OK. So I'm going to run the workload again. So it should be back to my nominal rate at some point in time. Okay, it's around 30. And as you can see, before it dropped to like 20 batch requests per second. And now I turn on auto-tuning. Sorry. So I need to restart here. OK. So again, I have my workload running. Let's see if it starts populating something here. It has. OK. So the line is my baseline here. Let me introduce a regression again. And it starts to go down. Yes, it tanks, as you can see here. And it doesn't come up much further. And now, at this point in time, I have a good plan and a worse plan in Query Store. So what happens is, if I turn on auto-tuning, what I see once it reacts, need to give it a second. Is that my nominal rate goes back to what it was before. What did it do in the background? Well, it looked at Query Store. It had two plans there, one that was working better for me, one that it was worse. It recognized the pattern that existed, and it went back to the previously known good plan, and there I go. I can see that my line went back to where I was before I introduced a regression in my workload. Okay? So this is an awesome feature to have turned on in SQL Server 2017, because if you're a production DBA, it actually allows you to just simply save some hours sleep. Yeah. You actually are able to sleep through crises that are introduced this way because the system takes care of it by yourself. You, however, can come in the morning. Let me go back, actually, because I forgot to show you something. You can come in the morning. You can review there was some blip in the evening, and you can actually understand if something, what went on and what was handled by the system. So let me terminate this batch here. I'm starting up Management Studio.
And keep in mind, this is not on by default. This is something you have to opt into. You have to turn it on. So if you want to do this, you'll need to enable this on the fly.
Exactly, ma'am. So I can show you the command here. It's very simple. you have to set automatic tuning and the feature force last known good plan to on. It's off by default. That's the only thing you have to do. And you are the DBA, you can come in the morning, and you can see, for example, that, oops, this was all cleaned up. Let me quickly do it again. So the scenario that runs. Okay, let me introduce the performance regression again. And once I do that, I should have data here to show you in a minute. Auto tuning turned on. So we have a number of DMVs, like this DMDB tuning recommendations. If you're a DBA, you can come here after the fact, and it will show you what was enacted by, oops, sorry. And of course, it's not working with me. Let's just move on from here. So but you have the ability to, as you saw there, for the system to take care of itself, and that severely reduces the risk that you may have post-upgrade. So then we have another tool in our tool belt, like I mentioned, which is the Query Tuning Assistant. We actually had a session earlier today where it was all about this one. So as we've seen, there is a way to go back to a previously known good state, but that's not necessarily what you want in every single occasion. Yes, it's a short-term fix because it's a short-term thing that will get you out of a production issue. However, and because you've gone through this process here. However, this QTA tool, the Query Tuning Assistant, can be an alternative that instead of necessarily having a good and bad state, it can move you to a third state where you are better off than the previous two. What do I mean by this? So if you ran through that upgrade process that we've mentioned a couple times today, that last bit there is what, in this case, automatic tuning is doing in SQL Server. It's going back by forcing the last known good plan. However, QTA can actually give you an alternative in this last stage. So you can go online and check out the video for that session. What it does, it's the ability to analyze your regressed queries, because it will still identify based on query store what queries regressed. But then, through your own knowledge of your workload, and by using this tool, it can actually analyze those queries, run those queries in the background. So we're only targeting select queries, by the way. It's only read queries. We can't run anything else. And it will, on the other side, it will recommend tweaks, knobs that you may add on those queries that will make them run better. So this is primarily to address the major risk after a database upgrade, which is cardinality estimation issues. Who here has gone before through an upgrade from an older version to SQL 2016 and above? Okay, a few people. How many of you had performance-related regressions after you've done that move and you bumped up DB compat? Few, okay. Those are not easy to get out of. Yes, you have this ability to go back in time to a previously known good state, but what if you need to do, you need to know what to do next in order for those queries to behave natively in the newer compat level without necessarily going back. So we have this tool, QTA, that is available in two flavors, if you will. SMS-based wizard experience, that will only be available in SMS V18, which will GA in a few weeks. It's not in the current preview. However, we have in current preview the PowerShell version of it. Now, the PowerShell version of the same tool means that you can script around it, you can use it at scale, point it to your servers, do an at-scale assessment on all of those, and come out through the other side with a full automation of this process that otherwise runs with your input. If you're interested in checking out this in your own environments, please send me an email. I'll add you to the preview program. I'll make the bits available to you, and you'll be able to use them. For now, still in the PowerShell version. I have a full README. You have a few examples on how to leverage that PowerShell. We even provide a wizard-like PowerShell experience for you to go through. So any questions on this? Has anyone here attended that session previously in the theater? Okay. So So you are able to leverage the PowerShell version of it right now if you want to. So here are some resources you can use, and all these slides we've been using throughout have a ton of notes. You'll be able to possibly download the slides, I think, next week.
I hope so, yeah.
Because there's dead download links, I think, in every session, but you'll be able to leverage those. There's a migration guide here. There's the tools that we mentioned that are currently public. So go in, start using them, leverage them to make sure that your upgrades are done risk-free. And to those that are still not planning your upgrade from 2008 to a newer version, maybe it's time to start thinking about it. I'll leave you with a few bookmarks. This is something we've accrued over time because the underlying URLs for example, the trace flag page, or the where to get information about the latest updates for SQL Server, or the SQL Server guides that have a lot of information on the internals of SQL Server. Those are ginormous URLs. So we've kind of created these smaller bookmarks you can go into. We obviously have the SQL feedback site. That's a new connect, quote unquote. So if you have any issues with SQL Server that are not pressing, affecting your production server, in which case you would go through support, please leverage that feedback site to provide us with ideas and feedback on SQL Server. We also have a number of T-SQL syntax conventions that you should observe as you are moving your code and migrating your code. If you have the chance to go in and make sure that you are leveraging what we think are the best practices in that regard. So we have also that page there, and I guess that's it.
Yeah. Anybody have any
questions?
last questions? Yeah.
Yes. Latency. So the question is, how does? Oh, so if the question is, can QTA uncover any issues related to your underlying ecosystem? No. So the query tuning assistant, much like the query store and all the features built on top and targeting query execution, have to do with the relational engine, meaning have to do with the layer of SQL Server that is responsible for parsing your T-SQL, optimizing it in a way that best executes your queries. However, if you have underlying disk issues, for example, those won't manifest. Those will not manifest as the query plan's shape or quality. It will just manifest as slowness, which you can see in some performance counters, for example. And so SQL Server will not optimize your plan differently, meaning it will not create a different plan if you're running in a server with 24 terabytes of RAM or 1 gigabyte of RAM. However, your ability to execute that plan will be different, but it will be optimized the same, right? That's what we're targeting, because as we move throughout versions of SQL Server, as we progress through database compat levels, we have introduced changes to the cardinality estimation and therefore the entire query optimization process. And those can enact changes in the plan shape, which then may turn into performance boosts or performance degradations once you actually put them into production. And that is still completely orthogonal to you having underlying disk issues or network issues, because those manifest themselves differently. Did that answer your question? Okay. Any other questions? Yes, one there. I'm sorry, can you use the mic? I couldn't really get what.
Under all issues, when we're doing a database migration, you recommend that we get the new database on a current compatibility level only under every condition. That way the query store could start. We have the baseline. And there should be no exceptions to that.
Yes. So the database compat level protection is, and there's exceptions for everything. But what we protect against is if you move to newer bits of the engine and keep the same DB compat level, you should not see any regression coming from the plan being optimized differently and then ending up in a performance degradation. If you do, we will treat it as a support case. So please come over to us, because that's not our expectation.
Yeah.
Okay?
And that's the reason for why you want to keep it in the same DB compat, because you're separating out what could be a platform issue from what could be an application issue.
If we run the tools you recommended to help us migrate, and we have that documented, and we keep it at the same compatibility, and then performance degraded, we open up a case and we get it escalated right away.
Yes, because
Yes.
the statement is
It narrows
everything else,
down the field, yeah.
yes, everything else being the same in the ecosystem, meaning you are moving to a comparable server with comparable resources. The only thing that you're keeping the same database in the same DB compat level, you are running the same exact application on top. You are not making application changes that may change the workload. So if everything else is the same, the only change was the version of SQL Server engine that's running, then yes, that is deemed a support case for us.
Okay. Yeah.
The auto-tune functionality that you showed us, that's going to be available in SQL Azure?
That is available in SQL Azure. That and actually much more. So there's a reason the feature itself is called auto-tuning, because it's an umbrella feature for a number of other enhancements. So in SQL Server 2017, the box version, the only thing that's in that version sits under this umbrella is the ability to go back in time to previously known good plan. In Azure, however, it has this one, and for now it has an added one, which is the ability to, on the fly, by the way, you turn this on or off at will. It's not on by default. But it has the ability to, again, analyze the workload as it's running, analyze the opportunity to uncover missing indexes that may be needed. Actually, if you allow that configuration to act, enact the changes to add those indexes, continue to monitor the workload. If those indices are doing what they're supposed to do, fine. If they actually introduce regression, we will then remove the indexes that we just created. So basically, it's auto-indexing under this auto-tuning feature in Azure. So this feature is not in the box, it's only in Azure.
Nice. Thank you.
Yep.
Absolutely.
Anything else? Yep.
Yes, question here? So the question is, in light of what I just said, if you're using ISV products, should you use auto-tuning? If you're talking about the automatic plan regression correction, I would say yes. If you're talking about the auto-indexing feature, that all depends on what your ISV has in their support fine print. There's no reason why they shouldn't, namely because the feature is reactive to itself. It will look for an opportunity to improve, it will enact that change, but if it didn't improve, it will roll it back. But in the end of the day, it's up to the fine print on that support statement for you to go through. But that specific feature of auto-tuning is only available in Azure as we speak. There was another question? Yes. I'm sorry? If it goes through, so the question is, does these go through SSIS packages? If the SSIS package is executing T-SQL, yes. It does not crack open and analyze SSIS packages themselves. It will only analyze at the SQL Server engine layer. That's where we are running the analysis and capture, right? So you can't point it to a SSIS package and say, analyze that one. Yep. Any other questions? Well, thank you everyone for being here all this time.
Thanks, everybody.